Good afternoon, all of you. Welcome you all to this second day of 3 days online FDP session on networking simulation using NetSim software. So today we will discuss about some brief introduction of NetSim and mobile ad hoc network and its attacks. We will basically discuss the Sinkhole attack. So we will design and analyze a MANET scenario using NetSim software, and then we analyze a Sinkhole attack in MANET, and we'll link it with NetSim and implement it. So we'll discuss your question and answer after the presentation. So there is a brief introduction of NetSim for those who had not attended yesterday. So just an overview. So NetSim is a scientific tool. So NetSim is a scientific tool for designing and validating networks and protocols. So hence it has a lot of relevance in protocol research and development. And in defense, it is used for simulating network-centric warfares. It has a wide range of technologies which is possible to simulate in NetSim are Internetworks, which is having LAN, WAN, and wireless LAN. Then mobile ad hoc network, WiMAX, cellular network that is having GSM and CDMA. Then cognitive radio network, LTE, wireless sensor network, which includes ZigBee. Then IoT, Internet of Things. In NetSim standard version, there are two versions of NetSim. One is having the GUI interface in which we can design and analyze all these technologies. And there is a standard version where users are provided with C source code of network protocols which are implemented based on IEEE and IETF standards. So the purpose of this C source code is to enable the users to edit the standard protocol source code and according to their own requirement, and they can link it with NetSim and analyze the performance of their newly designed protocols. NetSim has some customer segments. These are varying from industries where it is used for networks and design and validation, and in defense lab it is used for network-centric warfare simulations. Then in R&D labs it is used for protocol development and new protocol technology testing. Then in academics, we have a academic version where we can use it for network labs in our BTech and MTech syllabus. Then advanced network labs and the PhD thesis and project MTech projects. Now the NetSim has been divided into some components where standard user can make a selective choice while using NetSim. So there is a list of content of each component and the corresponding IEEE and IETF standards referred during implementation. So for illustration, component 1 consists of protocols implemented in wireless LAN, WAN, like Ethernet, IEEE 802.11, ABGA and AC. Then component 1 is the base components, that is all other components require component 1 to run. Similarly, component 2 consists of network based on legacy network. Then component 3 is border gateway protocol, BGP network. Then component 4 is having advanced wireless network, that is MANET and WiMAX. MANET works on these four protocols, that is DSR, AODV, OLSR and ZRP protocol. And component 5 is having cellular network, which consists of GSM and CDMA. And component 6 is having wireless sensor network, IoT, and personal area network. And component 7 is having cognitive radio network, and component 8 is having LTE and LTE advanced. Is for military radio, that is for professional version. Now we talk about the wireless network. So the wireless network can be divided into two parts. First is infrastructure based network, which consists of our traditional cellular system, which is having base station infrastructure, and wireless LAN, which is using infrared or radio links. Though these are very flexible within the reception area, but they have very low bandwidth compared to wired networks. Then other is ad hoc network. And ad hoc networks are very useful when infrastructure is not available. It can be used for military application, rescue, and home networking. So we today talk about this ad hoc network only. So this is a pictorial view of comparing infrastructure and ad hoc network. So where in infrastructure network, we can see the devices communicate among them using access point connected through wired network. So devices are connected to access point and access points are connected to the wired network or wired LAN. But in ad hoc network, devices communicate among them using a set of protocols like DSR, AODV, OLSR, or ZRP protocol. So we need not require an infrastructure in ad hoc network. So this is the architecture of ad hoc network, where devices communicate directly within a certain range in their basic service set. In the picture, STA or station is given, which is a terminal having access mechanism to the wireless medium, and the IBSS, that is independent basic service set, are a group of stations using the same radio frequency. So this is the basic architecture of ad hoc network. So why ad hoc network? Why we use ad hoc network? So we can see setting up a fixed access point and backbone infrastructure is not always required. So infrastructure may not be present in the disaster area or war zone, and infrastructure may not be practical for short range radios. Then in ad hoc network, we do not require a backbone infrastructure support, and these are very easy to deploy in and they are useful when infrastructure is absent and destroyed or impractical. So for these requirement, we use ad hoc network. And these are some applications of ad hoc network where it is used in civilian environment, emergency operations, personal area networking, and military environments. So in civilian environments, we can see it is used in taxi cab networks, in GPS, and in meeting rooms for conferencing, then a sports stadium, and then in boats and small aircrafts, then in emergency operation for search and rescue, then policing and firefighting. Then personal area network, it is used in cell phone, laptops, earphone, wristwatch, or a smartwatch we use these days. Then in military environment, it is used in ground warfare scenario it is used, where infrastructure is not readily available. So we use this ad hoc network, but it has also some challenges in the mobile environment. So these are the limitation of wireless network, that packet loss due to transmission error can be occurred. and some capacity links are variable, so we can have the losses from there also. Then frequent disconnection and participation of the devices occur, and then limited communication bandwidths are there, and broadcast nature of communication can also affect our wireless network. Then these are limitation imposed by mobility. So in the Ad-Hoc environment, we dynamically changing the topologies and routes. Then we have lack of mobility awareness of system and applications. Then there is very common limitation of power, that in mobile hardware we have short battery lifetime and limited capacities. So these are some challenges in this Ad-Hoc environment. So now we will discuss about some attacks that will occur in mobile Ad-Hoc network. This is a very common attack called Sinkhole attack. So as we know, it is very severe attack in mobile Ad-Hoc network, in which a malicious node create a wrong route to pretend itself to be destination node and receives the whole traffic without further transferring to the actual destination node. So in our MANET scenario, one of the nodes act as a malicious node. It sends some route reply to the source so that it acts as a destination and gets all the packets in the network. So that's why we called it malicious node. So it mainly affects the performance of DSR protocol. So in DSR, source sends RREQ, route request packet, before sending the whole traffic. So on receiving this RREQ and sends the route reply to the source to send the route information and then sending the traffic. It's possible to send route reply by some other intermediate nodes if they have route information. So the malicious node take this benefit and send route reply to create a non-existing or fake route. So source node sends route request to this malicious node and receives route reply from it. Then source find it most appropriate path to send all the information to this malicious node, which pretends itself to actual destination node. So all the traffic now goes to the malicious node, and it can further modify the packet information or completely vanish it from the network. So this is about malicious.c file. So for implementing it in NetSim, we have to add this malicious.c to the DSR project, which is having these below functions. These three functions have NetSim DSR malicious node. This is to identify whether this node is malicious. Okay, so this function is used to identify whether a current device is malicious or not in order to establish malicious behavior. And second one is malicious route add to cache. This is to add a fake route in the network to establish connection from the source. And the third function is a malicious process source route option. So that is to drop all the received packets from the source, instead forwarding it to the destination. So this is the main function we use in malicious.c file. Now here we can understand the scenario where node 1 is the source node and node 2 is the destination. Node 6 is the destination and node 2 is the malicious node. Node 1 is sending traffic to node 6. So our actual destination is node 6, but node sends false information route reply to node 1 so as to pretend itself to be the actual destination and receives all the traffic. I'll show you in the software how we can implement it. So for handling this sinkhole attack, we have an intrusion detection system. So intrusion detection system monitors the network for malicious activities, and once abnormal behavior is sensed, it takes preventive measures to recover from the attacks, and it keeps track of the network in future also to avoid such incident. Now for implementing it, we have two major functionalities. One is watchdog and second is path rater. So watchdog timer is added to each node in the network. Then the timer starts the moment a packet is sent. Once the packet is forwarded to the next hop within the watchdog time duration, and if the next hop is malicious, then it need not forward the packet as per the sinkhole attack implemented. So counter is used to keep track of number of time watchdog timer expires. So once the counter reaches the failure threshold, the current node marks its next hop as malicious and send it for blacklisting. Then second one is path rater. It adds malicious node to blacklist, and it validates routes by verifying route reply and discard route reply if blacklisted nodes are present in it. So these are two main major functions in IDS. Okay. So for implementing IDS in NetSim, we have to add watchdog.c and pathrater.c files in the IDS project. So watchdog.c has two major functions. First is add watchdog timer, which adds a watchdog timer to each node in the network. And second one is watchdog timer execute, which checks the packet is sent before timer expiry and checks if failure threshold is reached. Then in pathrater.c, these two functions are there. First is add to blacklist, which adds malicious node to blacklist of the current device. Then second one is verify route reply, which checks if the IP address in the route reply contains the IP of any blacklisted node. So this is the scenario of IDS in NetSim, where we have 6 nodes. One is source and 6 is destination, and we have 2 intruders, 3 and 4. So when we run the IDS, I just show you in a small video how the IDS works.
We see that node 1 sends DSR route request to which node 2 replies the
So it is
fastest.
sending the route request to this node, malicious node.
To node 2 to be forwarded to the destination. Node 2 being the malicious node doesn't
So this is
forward
your malicious
these
node.
packets to the destination node.
It doesn't forward this
Node 1
packet to
runs a
destination.
watchdog timer of 2 seconds and finds
Now,
that packets are not getting
now
forwarded.
2-second
Node 2
watchdog
triggers
timer is
activation.
running.
Once the count of packets reaches the failure threshold, the node is detected as malicious node, and any
Now
route from that
after the
node is deleted
threshold
from the route cache.
failure,
After that,
it is
node 1
detected as
sends
a
packets
malicious
to
node,
node 3,
and it
which in turn forwards the packets to the
now
destination
forwarding
node.
the packet to
Thus,
the
the
destination.
malicious node is detected by the intrusion detection system.
So malicious node detected,
Packets now
and
traverse
now
the
source
route
is sending
from
to the
node 1 to
destination
node
itself.
3 to node 4 to node 5.
So this is how IDS works. So now I analyze the metrics. comparison of network performance. So these are the comparisons of throughput when these three graphs are there. First is for normal working, and second is for after attack, and third is for with using IDS. So we can see in the change in the throughput, the normal working is having the throughput very high, and when the sinkhole attack works, throughput is almost zero. But when apply IDS, it has some throughput. So it improves the throughput after applying the IDS. Same is in the application delay. Application delay is more in normal condition. Then in attacks it is zero. Then applying IDS, it has some value. These are research areas in MANET, which we can use for our research: routing protocol, location based, power aware, quality of service in Adhoc network, intrusion detection, performance analysis, and vehicular Adhoc networks. Okay. These are our some customers who are using NetSim. Now we'll go to the software and see how we can work on NetSim. So first of all, we will analyze. I just open some ready-made project for you. Where we will analyze this is the MANET scenario. We are having 6 nodes. When you open the MANET scenario, all the nodes are disabled. Only this wireless node is enabled, because we need wireless node in the MANET scenario. No other infrastructure is required. So we just drag and drop these devices into the environment. We can set the values of the environment, and these are the devices. We have aligned them in a row by editing their positions. You can see in properties of first node, where we have given them the location of 250 and 100. Then we can define the mobility model of the devices. Either it is random walk, random waypoint, group mobility, or file-based mobility. So we just given them random walk of 10 milliseconds, 10 meter per second. So what we are analyzing here, we have set the velocities of all the nodes to 10 meter per second, and we are simulating and seeing the throughput. Then in the second scenario, we will increase the velocity to 10 to 30 and see our throughput. Then we will increase our velocity for 30 to 50. So on increasing the node mobility, their velocity of the node, how it will affect our throughput, that we will see in this scenario. So apart from this global properties, we have transport layer properties, where by default we are having UDP protocol, and segment size is given there in bytes. Yesterday also I have shown about this information tabs. If the parameters, most of the parameters are given there. So if anybody want to study about these parameters, they can click on this information tab and have this information about these parameters. Click on any of the information tab, you can have this information. Then in network layer, we have the routing protocol. By default it is DSR. We can change it to AODV, ZRP, or OLSR. Acknowledgement type we can define whether it is network layer or link layer. Then in interface of wireless, we are having network protocol of IPv4, then IP address, subnet mask, default gateway, ARP retry interval, retry limit. Then in data link layer, we have 802.11e enable. We can change it to disable if we require. Then retry limit, RTS threshold, rate adaptation. Yesterday I have shown that this rate adaptation algorithm, this minstrel rate adaptation algorithm is added recently in the new version. So as it is a very effective rate adaptation algorithm, we use it. So in physical layer, we can define the standards A, B, G, N, and AC. In transmission type, transmitting power, SIF is fixed for 10 microseconds. Then frequency band, bandwidth, CCA mode, ED threshold. Then standard channels are given there, you can change it. Then power source, either it is mainline or battery, you can define. So these are the properties of wireless nodes given here. So we can accept it. So for node 1, we have set the 10 meter per second. Okay. Then likewise we can see the properties. So here also we have given 10 meter per second. And this node also we have given 10. We just click and accept for 10 meter per second. Then we just accept it. Now here we are seeing this line that shows the applications. So in application tab we can see we are having 3 applications. So when we click on one of the application, we are having application type of custom, email, HTTP, constant bitrate, video, voice, database, FTP. These kind of application we can send on any of the network. We have to just define the source ID and destination ID. Here in first application we are having 1 to 4. That is from 1 to 4 we are seeing a line of custom application from 1 to 4, then 5 to 6 and 2 to 3. So second application is having 2 to 3, third application is having 5 to 6. Their packet size and inter-arrival timing also you can define. Packet size can be changed from constant to exponential. Its distribution can be defined and its value can be defined from here. Then inter-arrival timing, the packet's arrival can be defined according to their distribution, either it is constant or exponential. Then timing, inter-arrival timing you can define in microseconds. So we just accept it and see how we can see the result. So we just click on the run. So now it has given this performance metrics. Yesterday I have also described this performance metrics about the network metrics, link metrics, application metrics, ARP metrics, and link throughput, application throughput. All these are given there. So this is your overall metrics about simulation timing, packet transmitted, errored, collided, and this is bytes transmitted and payload transmitted. So now here we have to see the application metrics first, where it will give you the overall throughput of the network. Here we can see we have given 3 applications of custom type from 1 to 4, from source 2 to 3 and 5 to 6. And this is the packet transmitted and this is packet received. And this is your overall throughput. Okay. So when we add it, we can get the overall throughput of our network. So for analyzing it, we have to add it. So we just added the data in the Excel format. I'll show you the graph in the last. So we just comparing this very fast. So we just click here. Now this is the second part where we have defined the velocity of the nodes to 30 meter per second. Okay, so we just have to accept it for 30 meter per second. Okay, so we accept it and we can run the simulation. So it is taking some time for simulation. So now we will see also the animation of this uh, result, because we have increased the speed. So the mobility have increased very much when we have increased the velocity from 10 to 30 meter per second. So when the velocity increases, there will be more movement between the devices, and the more data will lose, and the throughput will decrease accordingly. So as we increase this velocity, its throughput will decrease. That's what we are analyzing. So here we can see some drop in our throughput. When we combine this overall throughput, we can see. So we just see the packet animation. When we run it, you can see the custom type of packet moving from 124, 223, and 526. And this is the textual format data given here. So when we increase the animation speed, we can see some movements between the devices also. So we're just increasing the simulation timing here to see the movement. So after some time, it is having some movement. So we can see in the status also now error is occurring so fast as the movement have increased. So that will result into some errors in sending the packets and decreasing the throughput. So likewise, we can see the third one, where we have given the velocity of 50 meter per second. We have increased from 30 to 50. So we just accept it. And run the simulation. Now as the simulation is running, I'll just show you the exact result. So here you can see in the graph also and the text format, when mobile velocity was 10 meter per second, its throughput was almost 0.466, and on 30 meter per second it is almost 0.44, and on 50 it is decreased to 0.20113. So when we plot it in graph, you can see the decrease in throughput when we increase the velocity. So that is we want to check. So now it has been simulated. So we can see there are a lot of decrease in the throughput, and we can see in the animation also there will be faster movements among these devices. We have to just increase the speed. So status, we are having the success, success, success. Now as the movement increases, it will be some errors. Now we just increase the simulation timing just to see how the status changes from success to error. So we can see a lot of errors are now coming, and our packet is being lost very fast. Okay, so that's what we want to study, how the speed changes the throughput of the MANET devices. And these are all I have shown yesterday also about packet trace and event trace. And the attendees who have not there yesterday, I'll just open them, the packet trace and event trace. So this is your one by one information of the packets which are sending in the scenario, MANET scenario. So it is having each and every information of the packets, their path being forwarded, their values, either it is successfully sent or not, all are given there. You can use the tools of Excel to view its result accurately. So let's filter some packets. Let's say for packet number 1. So we have packet number 1 having custom type of application, and these are control ID, source ID, destination ID, the path where it is being forwarded, simulation timing, its packet information, okay, its value, okay, all the information about the packets are given there. Likewise, we have event trace. as NetSim is a discrete event simulator, so all the simulation occur in events. So we can see all the events occurring in the network through this uh, event trace report that generates after the simulation. So for packet capturing, you can enable the Wireshark software also that can capture the packets while running the simulation. These are the events performing in the network. You can analyze one by one these events. These are the protocols. And these are some graphs generated in link throughput and application throughput. And these are applications. Now we were talking about the attacks. So I have some source code for Sinkhole attack. So we just have to run those Sinkhole attack codes. So this is a Sinkhole attack. We have to run this netsim.sln file. So that will open this DSR protocol in Visual Studio, where we have a malicious.c file, what we were talking about in presentation. So it has malicious.c file where the code is written for the malicious node. So here we have taken node 2 as a malicious node. We are having 6 node of MANET scenario where node source 1 is sending the packet to destination ID 6, and node 2 is the malicious node. So we just have to build it. When we build this scenario, we will have a libdsr.dll file created in the DLL folder. So we just have to copy this DLL and link it to the NetSim's installation directory, where you can see in the NetSim standard bin folder is there. So yesterday I have shown in through a Hello World program how we can link it these binaries of NetSim to the NetSim GUI. So here all the protocols are given in DLL. So we have already made a Hello World program here. So we just remove this DLL, and this is our default DLL. So that we have rename it so that it will attract our original DLL. So we just copy this libdsr.dll that is having the sinkhole attack feature in it. So now when we work on the MANET scenario, our edited DLL will work. So this is the scenario where we are having 6 nodes, having source node as 1, destination node as 6, and this is your malicious node. So when we send the packets from source 1 to destination 6, malicious node will send the root reply and gets all the packets from source ID 1. So let's create that scenario. So we have already created here node 1 to 6. We are sending packet 1 to 6 of CBR application, constant bitrate. Packet size and interarrival timing are same. Okay. So here, when we run this simulation, so we have changed some files in the DLL, so it will show a message in press when you continue. So we just put enter and the simulation will run. So we can go to the packet animation and see how the sinkhole attack will work. So it will send the root request. So we can see this node 2 is sending root reply to this node 1, and it is receiving the packets from source 1. You can see here the green line shows the application of CBR running, and it is not sending the packet to node 6. Rather, it will sending the packet to node 2, as this is a malicious node which acts as the original destination and receiving all the packets. So here it is continuously receiving the packets rather than node 6. So our malicious node code is working. So it continuously acts as a destination and receive all the packets. So this is about malicious node. So when we want to implement the IDS or intrusion detection system, we have to add those codes. So when the IDS will work, it will repair the path, and it runs the watchdog timer for a threshold value. When the threshold value reaches, as I've shown in the video, uh, it defines the node 2 as a malicious node, and it repair its path from the node 6 and send the packets to its original destination, that is node 6. That is about sinkhole attack and its IDS system. And this is good NetSim analytics tool I've shown yesterday also. And this is for comparing the matrices of different scenarios. Let's say we are having MANET scenario of we are having different MANET scenario, and we are comparing those matrices. We are having 4 matrices of same technology, that is MANET, and we are comparing these matrices on these parameters like simulation timing, packet transmitted, packet errored, packet collided, byte transmitted, payload transmitted, and overhead transmitted. So we can compare these matrices over these values. This is the tool given. Okay, so likewise we have edited this DSI protocol for Malicious.c. We can edit the IDS source code and work for IDS also. And likewise we can edit different protocols, and we can make our own protocol also and save it in DLL extension and link it with NetSim. So in installation directory all the protocols are given there. You can make your own protocol and copy it here and link it to NetSim GUI. It will work. Okay. So we are having the help manual of user manual, source code help, and experimental manual. So for academics, we have given experiments of around 22 experiments on different technologies. So these are the experiments given on different technologies. When we click on any of the technology, we are having the theory part for study of the students, then procedure, how we can work on it. Its values are given there on which the default values on which it will work with their screenshots and the results what we have analyzed. So it is for practice purpose. Likewise, we have user manual for overall software introduction and its working. Okay, overall networking. When we click on this, we can study different technologies in detail. So I've done with my presentation. If you have any query, you can ask me by writing your question in the text box